Okay, let's solve this question. A point moves along an arc of a circle of a radius r. Its velocity depends on the distance covered s, as v is equals to a under root s, where a is constant. Okay, find the angle alpha between the vector of the total acceleration and the vector of velocity as a function of s. Okay, so here is a circle of radius r, and there is a point that is moving along the arc of the circle. I mean, that's moving tangential to the circle with velocity is equals to a under root s. S is the distance it is covering. Okay, so as this is a function of distance, so velocity is not constant, and therefore it will have a tangential acceleration along the path. Also, as it is moving in a circular motion, it will have a centripetal acceleration, a centripetal. Okay, what we need to find is, we need to find the angle between the vector of the total acceleration. So what will be the, this is tangential acceleration, this is centripetal acceleration. So total acceleration will be the resultant of these two. Okay, it will be somewhere like this. If we draw a parallelogram, it will be something like this. This is our resultant acceleration, total acceleration. Okay, so they want to find the angle between the velocity vector and the total acceleration, this. Okay, we can also find this angle between the tangential acceleration and the total acceleration, because a velocity vector is in the direction of tangential acceleration. So let's solve this question. Okay, so velocity is given as a under root s. Velocity square will be a square s. Okay, this is equation number 1. What we can do is, we can find centripetal acceleration, which is equals to v square by r, which is equals to, v square is given, therefore a square s by r. Then a centripetal will be equals to a square s by r. This is equation number 2. Okay, now let's find the tangential acceleration. So as we know, v square is equals to a square s. We can differentiate this whole expression with respect to s. What we'll get is 2v dv upon ds is equals to a square, as a is the constant. So like, you need to identify that this expression v dv by ds is acceleration. How? A is equals to dv by dt. Okay, you can write this as dv by ds times ds by dt. Okay, you can cancel ds out, and you will left with dv by dt. Then this whole, and this part is basically velocity, ds by dt. So this acceleration becomes v dv by ds. So this is expression that you will came across a lot of time, and you need to remember this. You need to identify this expression as acceleration. So this is tangential acceleration. So 2 times tangential acceleration is equals to a square. This a is constant, this a is our tangential acceleration. So a tangential is equals to a square by 2. Okay, we know both of these acceleration now, so we can easily find the angle alpha. We know that tan alpha is equals to the acceleration perpendicular upon the acceleration adjacent. Okay, so it will be a square s by r upon a square by 2. Okay, So from this you can cancel and this a square by a square, and you are left with 2s upon r. Hence alpha is equals to tan inverse 2s upon r. This is our final answer, as it is asked that tell alpha in terms of as a function of s. Okay, so this is our answer.